40% of the corn grown in the United States does not become food. It becomes fuel. Not tortillas, not animal feed. Fuel. Pumped into gas tanks at 150,000 stations across the country. The molecule doing the work is ethanol, the same molecule in the bourbon on your shelf. But here's something that might surprise you. That bourbon, the gasoline in your car, and the hand sanitizer you squeezed this morning all start in the same place as a fermentation tank with yeast eating sugar. One molecule, 3 completely different lives. This is how ethanol moves from a cocktail glass to a gas pump to a hospital door, and why it was never the liquid that changed. Nobody invented ethanol. Yeast did. A single-celled fungus that has been alive on this planet for hundreds of millions of years, eating sugar wherever it finds it in rotting fruit, in wet grain, in honeycomb cracked open by rain. Every time yeast eats, it leaves 2 things behind: carbon dioxide and ethanol. The bubbles rise, the alcohol stays. Humans figured this out roughly 10,000 years ago, probably by accident. Somewhere between Mesopotamia and the Yellow River Valley, someone drank liquid that had been sitting too long and felt different afterward. They did not understand fermentation. They did not know what ethanol was. They just knew the liquid had power. For most of history, that was enough. Wine, beer, mead, all fermented, all capped at about 12 to 15% alcohol. That was the ceiling because yeast poisons itself. The ethanol it produces kills the organism that made it. To get past that barrier, humans needed a new tool. Around the 8th century, Arab alchemists developed distillation heating fermented liquid until the ethanol vaporized first, then catching the vapor. They were not trying to make drinks. They were trying to make medicine. Nobody planned it. But distillation unlocked everything that came after spirits: fuel-grade ethanol, industrial solvents, surgical antiseptics. One technique, one molecule set free. Here's the thing nobody tells you. The bourbon in your cabinet and the ethanol blended into your gasoline were born in the same kind of facility, from the same kind of grain, through the same biochemical reaction. The difference is not the molecule. It is where humans decide to split the line. Start in a field: corn in Iowa, sugarcane in Brazil, grapes in Napa Valley. The source shapes flavor and yield, but underneath, the chemistry is identical. Sugar is the raw material. If the source is corn, and in America, it usually is the starch that has to be broken down first. Enzymes called alpha amylase and glucoamylase cut long starch chains into simple sugars that yeast can actually consume. At this stage, the mash smells like wet bread. Warm, slightly sour, alive. Yeast enters the tank. Temperature is held between 30 and 35 degrees Celsius. Too hot and the yeast dies. Too cold and it sleeps. Over 2 to 4 days, ethanol accumulates, then stalls around 12 to 15%. The yeast cannot survive what it created. Distillation takes over. The fermented liquid is heated. Ethanol boils at 78.3 degrees Celsius. Water boils at 100. The vapor richer in ethanol rises through a column, passes through a condenser, and drips out the other side. Purified, concentrated, still the same molecule. This is where the road forks. Beverage path. The distilled spirit is diluted with water, aged in charred oak barrels for years, blended and bottled at around 40%. Taxed by the TTB, sold at a liquor store, poured over ice on a Friday night. Fuel path. The ethanol is dehydrated molecular sieves strip the last traces of water because water corrodes engines. The dry ethanol is blended with gasoline and labeled E10 at the pump. You have probably burned ethanol on your morning commute without thinking about it. Sanitizer path. The ethanol is diluted back down to 60 to 70%, mixed with glycerin and sometimes hydrogen peroxide, gelled and bottled. Shipped to hospitals, schools, office lobbies, and the dispenser you press on autopilot walking into a building. Industrial path. Chemicals are added: methanol, isopropanol, denatonium benzoate, one of the bitterest substances known to make the ethanol undrinkable. Not because the molecule changed, because the law says untaxed alcohol cannot be consumed. The additives are a legal fence around the same compound. One process makes the molecule. 4 systems decide what it becomes. Walk through your house and count how many times the word alcohol appears. Your kitchen has bourbon ethanol at 40%, barrel-aged, built for flavor. Your garage has E10 gasoline ethanol dehydrated and blended with petroleum, built for combustion. Your bathroom has rubbing alcohol, check the label. It probably says isopropyl alcohol, not ethanol. A different molecule entirely. Same word on the front of the bottle. Now open the hall closet. Hand sanitizer ethanol at 60 to 70%, gelled, built for killing microbes. And if you have ever bought denatured alcohol from a hardware store, that is ethanol too. Same molecule as the bourbon. Intentionally poisoned so the government does not tax it as a beverage. 5 products, 3 different molecules, 4 different legal classifications. Same word on every label. Here is where the story flips. 2 bottles of hand sanitizer on the shelf. One says 99% alcohol. One says 70%. You reach for 99. Stronger is cleaner. It is not. 99% ethanol evaporates almost on contact flashes off the skin before it can damage microbial cell walls. Water slows the evaporation, gives the ethanol time to penetrate and unfold the proteins that keep microbes alive. 70% works better because it stays longer. The weaker bottle is the stronger product. And one thing most people miss. Alcohol is a disinfectant, not a sterilizer. It handles most bacteria and many viruses. But it cannot destroy bacterial spores. Your sanitizer bottle does not say sterile. It says antiseptic. That is chemistry drawing a line. Next time you pick up anything with the word alcohol on the label, give yourself 5 seconds. Read it differently. Which alcohol? Your parents kept a brown bottle of rubbing alcohol in the medicine cabinet. You keep a pump of hand sanitizer in the car. Different molecules, different mechanisms, same word. Same assumption that they work the same way. They do not. What concentration? 40% is a spirit, 70% is a sanitizer, 99% evaporates before it finishes the job. The number is not a quality grade, it is a function. What was added? Oak and thyme in bourbon, glycerin in sanitizer, gasoline in E10. Denatonium benzoate in the hardware store bottle is one of the bitterest substances known, added to make one sip unbearable so the tax code stays intact. The molecule never decides what it becomes. 4 federal agencies oversee 4 versions of the same compound. Alcohol is not a drink that happens to have other uses. It is a molecule humans surrounded with rules, taxes, additives, and purposes. The drink is just one corridor in a much larger building. A glass on the table, a nozzle at the pump, a dispenser at the hospital door. They still do not look connected, but now you know they are. That is the process. We reveal how things actually work, one story at a time. If there is something you would like us to explore next, let us know. Until then, trust the process.